Which of the following are arranged in an increasing order of their bond strengths, right? O2 minus, O2, O2 plus and O2 minus. So basically we have four species: O2, O2 plus, O2 minus and O2 minus, right? These are the four species. Now the bond strength is calculated by the bond order. So that means we have to first of all calculate the bond order. More is the bond order, greater is the bond order, basically greater is the bond strength, right? Bond strength will be more if bond order is high. So we have to first of all calculate the bond order of these species. Now if I draw the molecular orbital diagram of O2, right? So let us see, O2 is having a total of 16 electrons, right? It is having a total of 16 electrons. It is saying 1s first of all. This will be sigma 1s. This will be sigma star 1s. Similarly, there will be for 2s. Now for 2p, for oxygen Z is greater than 7, right? That means the diagram will be something of this manner. This will be basically the diagram. This will be basically sigma 2pz. This is pi 2px. This is pi 2py, right? This will be pi star 2px. This will be pi star 2py. This will be sigma star 2pz, right? So this is basically the diagram. So for O2, what will be the configuration? It will be sigma 1s2, sigma star 1s2, right? Sigma 2s2, sigma star 2s2, right? These are basically the 8 electrons. Now we are left with 8 electrons more. So how will we fill that? This will be 1, 2, 3, 4, 5, 6. 6 electrons are filled over here. 2 remaining will come over here. That means the configuration will be sigma 2pz2, pi 2px2, pi 2py2, right? Pi star 2px1, pi star 2py1, right? So these are basically this is basically the configuration. Now for oxygen we have this configuration. So bond order is basically given by, here we have 1, here we have 1. Bond order is given by basically number of bonding minus number of anti-bonding. In 1s and 2s we can cancel out the number of bonding and anti-bonding because the number is same for anti-bonding and bonding, right? So they will cancel out. So the remaining will be for 2p. So what are the number of bonding electrons? It is 6 and anti-bonding is 2 divided by 2. So the bond order is basically, it will be 2. Bond order is 2. Now for O2 plus, what will happen? This electron will go off, right? That means for bond order will be 6 minus 1 divided by 2. It will be what? 2.5, right? Now for O2 minus, bond order will be what? One electron will come over here and one will come over here, right? That means it will be 6 minus 3 by 2. It will be what? 1.5. And if I talk about O2 2 minus, it will be bond order will be one more electron will come into the anti-bonding. So that means this will be 6 minus 4 by 2 because these are the 6 electrons and 4 electrons are over here. So this will be 1, right? So for O2 we calculated the bond order was 2, it was 2.5, it was 1.5 and 1. So basically the bond strength will be highest for what? It will be highest for O2 plus, right? So that means O2 plus, then O2, then O2 2 minus, then O2 minus. There is a mistake over here. This should be basically O2 minus, right? So that means this option, B option is correct.